Hi, welcome to the Ben and Chris show. I'm Chris.
I'm Ben.
And today we're going to be talking all about data. So, Ben, do you want to, should we add to the screen and get started?
Yeah, sure. Let's. Okay. So as Chris said, we're talking. Well, last week we talked about functions, how we can use functions for, and what their purpose are. This week we're going to look at arrays. You might have heard of arrays before. Python also uses the word list, and I suppose there is a distinction between an array and a list. But in Python, we just work with lists. So we're going to look at lists, and also we're going to look at files. So these are two very big parts of data analysis and working with data in Python. Lists are probably one of the most common ways you can store data in Python, and files, offers some kind of permanent storage that we can store that data in. So what we can do is we can take stuff from the file, take data that's saved in a file, and actually, propagate a list with that data. So generally, this is one of the most common things we do in Python is have just lists of data, and we're reading stuff in from files.
Actually, this is true of most software, really, isn't it? Because most programs, because you'll often hear, again, if you're just new to programming or if you're going to get into programming, people talking about data structures or the data type, and the array style, and I would consider list within that is absolutely the most common use. We use them everywhere, guaranteed. Whenever you do anything on your mobile phone, in the back end, there's a whole bunch of arrays being processed. Even the way that icons are laid out on the screen, there'll be arrays that are doing that, or at least storing that information.
Yeah, you find arrays, as Chris said. You find arrays everywhere. Even in things like interfaces, you find it in things like you find it in things like scientific programs where you literally just have a bunch of data and you're reading it into this kind of array. But you find this, as Chris says, everywhere. If you have used any kind of software, well, think about the software you've probably used today, your mobile phone and stuff. Like Chris said, it lays the icons out on your phone using an array. That those icons are stored probably somewhere in some kind of list or array, and what the mobile phone is doing is actually iterating through that list and showing that stuff on the screen. So if you're, I don't think like the last, I don't know how many times I've written code in the last week or so, but for all the times that I've written code, say in the last week, every time I write code, I use an array in some way. It is one of the most useful features of a programming language, and it truly separates you away from the kind of simple programs we've been using where we ask for, and sure, yeah, they've got more complex as we've gone on, but the arrays and lists allow us to do so many powerful things. We can store data in one particular array. We can do something to that collection of data and transform it. So there's so much stuff we can do with arrays, and I think it's one of those.
There's a lot of reasons why we might want to use arrays instead of. So, if you have watched our episode on variables, for example, you might be wondering, well, why don't we just have a whole bunch of variables? If we want to store lots of information, why not have? So, Ben, can we do a quick example? I want two variables called first name and last name.
Okay. I guess I'll just Ben. Last name. I'll put my last name. Yeah. Okay. All right.
It always just says it on the screen, Ben. So we're not hiding our identities. So now this is fine if you have two names. Now I have three names, and I want to use the same structure. When I log into this, I want it to, this is a system that is going to store a load of user details, and I want mine to say Christopher James Headland. I want to say my middle name as well. You know what? Once, Ben, I convinced people for a year that my middle name was Jemima. But anyway, now suddenly our data structure doesn't work anymore. Now we have two variables, first name. Now Ben, let's do the same thing again, and let's have an array called name.
Okay.
Actually, no, just leave that up there. Below, just have array called name. And now let's put Ben Williams in that. So this is what an array looks like. Now we have both of Ben's names, Ben Williams, and both of those pieces of data sit as unique elements within that array. Now, if I want to put my name in, so let's have name 2. And we'll have Christopher. I love how it came with childproof.
Yeah, there we go.
So now we have all 3 names. Now, that same kind of structure, that array can work for 2 people. Now, here we've created 2 different arrays. We'll explain why if you were doing this in a commercial setting, you wouldn't need to do that. But again, so sometimes we don't necessarily know how many elements we're going to need to add. So a really good example of this, actually, let's delete all of that. And let's have an array called family. Right, now, Bob's family is just Bob. So there's only Bob in Bob's family. Bob is his own family, and good for Bob. But but that doesn't necessarily describe all families. Now let's delete Bob. Didn't like him anyway. I've got a really funny story about Bob at the moment, but anyway. Now we've got Sam's family. Now Sam's family has Sam, Phil, Charles, and Jemima. I don't know how to spell Jemima, do you?
I'm going to put that.
I think that's close to Jeremiah. But so again, now our family, we can expand that. So we can add more data to the family. We can add more elements to family. And if Sam had another child called Susan, we can just add that data in. So now we have one piece of data. So I was going to tell you a funny story about Bob. Tristan, my son, he's gone into this habit at the moment of he looks at an empty corner of the room or an empty chair and he waves and goes, "Hi, Bob." There's nothing there, and it's freaking me out. It's really freaking me out. Anyway, so that's why we might use an array.
Yeah, so there's the cool thing about arrays, you might have got it from what we were talking about, right? Is that a variable normally stores one value. So I have a variable called a here, and it has one value. It only ever has one value, right? The cool thing about arrays is you can have many things in one thing. And now we've been using strings, but you could actually have 5, 3, 9, I don't know, 8, and 7 or something, right? If I print out A, what you'll see is these square brackets. Now, whenever you see these square brackets, firstly, if you see this opening square bracket, it must be closed with a closing square bracket. So if I remove this, you'll see Python just gets very confused and it's like, what's going on? So you have to, if you're opening a square bracket, you have to close square bracket, and everything inside of these square brackets is the data inside this array. Now, the way we add elements to an array or a list, and when I talk about arrays and lists, the reason I say arrays is just because I learned this type of thing in a different language, and we call them arrays in that. Python, the official term is lists, but when I talk about arrays and lists, I largely mean the same thing here, so don't worry, get too much about that.
It's a good thing as well for people who are programming different languages or are aware of different languages. An array and a list is usually something a little bit different. Arrays usually have to some extent a fixed length, whereas lists you can append to them. And there's other deviations there, depending on the language and depending on what's implemented. But in Python. And again, if you picked a Python book off the shelf, much like Ben is doing now, the words array and list are often used interchangeably. But yeah, the technical term in Python is list.
Yeah, and Chris is exactly right. The reason we call it lists in Python is that lists don't have a fixed size. You can always add stuff to a list in Python. So what this means, what
approach to shopping lists.
Yeah,
there's always room for another bag of Doritos.
Yeah, shopping list is a good example actually. A shopping list you can think of as never complete, I guess. There's always room for Doritos, and you can always strike an item off the shopping list, right? And you can do the same thing here in Python. You can have a shopping list doesn't have just one thing. I mean, it wouldn't be called a shopping list. It'd be called like a shopping post-it note or something, or a shopping note. A shopping note would only contain one thing, whereas a shopping list has many items within it, and that's the whole point of a shopping list, right? You don't just.
Well, let's use this as an example, right? Let's create a list, an array called shopping, and let's just show what we can do with our shopping list. So my shopping list this week, Tristan's really into omelets. So I'm going to get some eggs. I'm going to get some cheese. There's always room for Doritos, so put some crisps.
I was going
to make you spell Doritos. I want some beef. Always room for beef. I want some mince.
Oh, mint like that, or mintus?
Both. Let's have both of them. Okay. I need some mince, and I need some mince. And let's have some bread. Cool. So that's my. I mean, yeah, that's my shopping list. Why not? I can make burgers, omelets, and I can have some mince afterwards. Perfect. So the first thing we want to do, we arrive at the shop. I'm going to read my list. So let's print the list.
So in Python, you can type in the name of the list here. So like shopping. If we run this, you'll see it has these square brackets. So it's almost just kind of repeating back to us what this is. And you might think, okay, that's great, but it's not really that useful. The cool thing, and the really cool thing about lists, right, and this is where it gets really interesting, is we can actually go through each one of these things one by one. So
let's do that. So let's go. So we've read the list. So we print shopping. Yep. Now I'm in the shop and I'm going to get buy things in order. I've got my refrigerated items at the front. I know you're not supposed to refrigerate eggs, but I do. So do you know you're supposed to refrigerate? No, you're not supposed to refrigerate eggs.
I no.
An egg expert told me. So right, so we're going to read the first item off the list. So let's just print one item from the first item from the list.
Yeah. Okay. So there's this notion of, it's called indexing in Python. If you ever see indexing, if you're looking at another article or book on Python, you might see this term indexing. And what indexing is like Chris said, if we want to just look at not just the whole list, we want to look at the first item on the list. What we can do is index into that list. So if I do square brackets like this and I put in 0, right, and I run that.
Why 0, Ben? Why not 1?
So that is a very good question. The basically nearly every programming language, I think with the exception of some languages like MATLAB,
NetLogo.
Yeah, NetLogo is another one. Most programming languages always start with 0 when we're indexing. They're called 0-indexed languages. And the reason for that is, well, I think part of it is convention, and second is it makes life a lot easier. I think
it actually makes sense from a point of the way numbers work, right? So if we in a binary, a decimal system where we're going up to 10, right? If we start from 0, we can get 10 numbers with just using a single character. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 characters. A single character, we can get up to 10 numbers. When we want to move to the next set of 10 numbers, we just add a 1 to the front of it. So we think as 10 as being the last number in a 10 number sequence. But it's not really. It's the index of the next set of numbers. I don't know if I explained that particularly well. But when we get through to 100, again, we add 1 and, index, I know what I mean.
No, I get you coming at, like the base of like 10. So in our decimal system we have we have 10 digits, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we also have 0. Now that's 10 digits, right? And when we come to 9, we've run out of digits. We've used 0, 1, 2. So what we do is we put 1 and 0. And that's the reason. That's one of the reasons we're starting here at 0.
Just a question: is this session on the same time every week? Yes, we're always on at 6 p.m. on a Thursday. Although we are doing something slightly different next Thursday. But yes, every Thursday at 6 p.m. we try and do one of these sessions.
Yeah.
Carry on,
mate. Okay, so that's part of the reason it starts at 0. Now, this is one of the things that confused me when I started learning how to program. Is I always instinctively went, oh right, I want the first item in the list. I'll put in 1. So this list contains eggs, cheese, crisps, beef, mince, and mince, and bread, right? So the first element of this list to me is eggs, right? And it is. But if we put in 1, we're going to get cheese. And that threw me quite a lot. And it's one of these things you just get used to. You get used to thinking that 0 is the first. And technically in this, 0 is the first. The real reason we index at 0 is because in memory, this is the elements start at offset 0. So that's kind of the real reason. But part of it is, if it's a bit confusing, just the more you practice, the more you get used to this kind of stuff. But 0, shopping square brackets 0, refers to eggs in this case. Shopping square brackets 1 refers to cheese. And you read this as shopping, or sorry, the first, well, in this case, second element of the array list, the list shopping. So 1 is going to give us cheese, 2 is going to give us crisps, 3 is going to give us beef. And you can see where I'm coming at here. If we start at 0, go to 1, go to 2, and so forth, we can actually end up getting each one of these in turn.
So let's try doing something different with this, Ben. So we know that we can now change the index on that array, and we can print out a different one. So let's go through this as we would do with a shopping list. So we've read our shopping list. We're now going for item 1. So we've got our item 1. Now, can I want a list, and I want another array called shopping cart. And another list called shopping cart. Now, as I get things from my shopping list, I'm going to put them in my shopping cart. So we can think of this as, I have my hypothetical, what I want here, and I have my actual, what I have got in the shopping cart. So now I have read that I'm going to get some eggs from that shopping line, that index 0. I want to add that to my shopping cart list. How would I do that?
So you could, I suppose you could manually put it in here, but the way to do this is a method called append. So a function called append, and as it says here, it appends an object to the end of the list. So if I add here, just to show you first. So if I have shopping cart here. So at the moment, if I print this out, you'll see we've got the list here. We've got eggs, which is the first item of the shopping list, which is here. And then finally here, we've got nothing, right? Because these two square brackets mean there's nothing in the list. Now, what happens if I add something like hello, right? You'll see that this list now contains hello. So if I do this, twice, I'm going to get hello twice. So what this append does is it adds on to the end of the list. Now, to go back to what what we were originally saying, you can take, if we want to put eggs in our shopping cart, we can append it to the shopping cart list.
So let's write a little program. So can we create a while loop?
Yeah.
Let's just do a while true. So while shopping while shopping is false.
Shopping like this.
Yeah. Right. Okay. So this is a loop that says we're going to continue doing this process until we've finished, and we'll close that off in a second. Now, what I want to do is do a we're going to loop through our not shopping because I've realized we've just used that array name somewhere else. While we are shopping, shopping.
It's shopping.
There we
are. False. Is that right?
Yeah. So what we're going to do is we're going to loop through, and we're going to take elements from the shopping list, and we're going to put them into the shopping cart.
Shopping cart dot append shopping, and then the index here that we'd have to pass in. I mean, we could
counter.
Yeah, let's make a counter, and we'll put in shopping counter here.
And we'll explain what we're doing through all this in a second. And as we put it on the shopping cart, let's remove it from the. Actually, no. Let's not do that. Okay. Actually, no. I've changed my mind. We're going to do this slightly differently. Okay. If you remove the remove the ignore me. Just keep doing it this way. This is fine. Right. So what I want to do, we've got while shopping is false. Now we're going to set that is shopping when the length of the shopping cart list is equal to the shopping list, the shopping array, and then we'll set is shopping to true.
Okay, so if I understood that right, if the length of the items in the cart is more than or equal to the length of the shopping, so just
oh, and actually, I've just realised I've done something completely silly. Just change the false to true because it doesn't make logical sense why that would be that way. We are shopping. I'm on a lot of I'm on a lot of antibiotics at the moment. My brain isn't working at its usual speed.
And I assume we need to add one to the counter here. So I'll just condense this into plus equals 1. Is that right?
Yeah.
And then if length of the shopping cart is equal to the length of shopping. So if you're not too sure of what this len is, it's quite easy. So say I've still got the code. I'll paste it back in a second. But say we have an array, a list of items. So let's call this items. And you've got cheese, eggs, I don't know, milk or something, right? Now there's 3 things in here. We can look at this and go, oh, right, cheese, eggs, milk. We know how many things are in there. But how do we get that through code? So if I do len, and len means length, as it says here, it returns the number of items in a container. So if I put in items here, len of items, give me 3. If I add another one, and I say, I don't know, water or something, we'll get 4. So all len does is it just gives us the length of the list, how many items are in it. So if I just paste this back, so what this is saying is what we're doing in this while loop is while we're shopping, right? Add to the shopping cart, because as we've got two lists. We've got a list of shopping that we want to get, and the shopping cart is the list of stuff that we have got, right? That we've actually put in the cart.
And in there, it's currently empty.
Yeah. So I'll take this out for now. So while we're shopping, add stuff from the shopping list into the shopping cart, add one to the counter. And if the length of the shopping cart is equal to the length of shopping, then is shopping should be false. Because what this is saying is if the number of items in your shopping cart, your trolley, your basket, whatever it is equal to the length of things in your shopping list, then you've got everything, because you've added.
I used to have this really annoying housemate who would say the thing as he was picking something up off the shelf. He'd go, "Got the pasta," and he would chuck it in. So I want to make this a Tom simulator. So as we append, let's also get it to print out got the and the item.
Okay, got the, and then let's just put in this case it's going to be shopping cart brackets counter, right? So should I give this a run and see what happens?
Yeah, let's just delete the thing at the top first.
Oh, this stuff.
Yeah. Don't need that anymore.
So just to review, right, we've got two lists. We've got shopping, which is a shopping list of things we need. We've got shopping cart, which is the contents of our trolley. Currently, this is empty. We've got this Boolean, which is shopping equals true. So we are shopping. And we've got a counter. So whilst we're shopping, whilst is shopping is true, then basically add the elements from the shopping list one by one into the shopping cart, then print it out, add one to the counter. Ooh. And then if the length of that shopping cart, if the amount of things in your trolley is equal to the length of the shopping list, then we're not shopping anymore, because we've finished, we've got everything. So let's run this. And we get, got the eggs, got the cheese, got the crisps, got the beef, got the mince, and got the bread. And then it finishes. So that's what we've essentially done here in a roundabout way, is iterated through this list. But you can see the utility of this, right? I could have a shopping list of any number of items. Here we've only got a few, but imagine if we had a shopping list that was, 5,000 items long. That's a very long shopping list, but this program would work in exactly the same way if we had two things in our list.
Paste those items 10, 12 times, right?
Yeah, so let's do this. That, I know there's repetition here, but that is a lot of items, right, in your shopping list. But this thing will just go through it, no bother. It'll go through each one. And you can kind of think of it as buying this item and putting it in the shopping cart. Now, this is really useful for us because we can store a hell of a lot of data in one thing and then just iterate over it and do things with it. And that is, this whole series about data analysis. This is incredibly useful for data analysis, because
let's look at this as being an actual piece of data. Then let's do something a bit more. So let's delete let's go back to the original list.
Okay.
Before we added 5,000 loaves of bread.
Yeah.
So instead of, let's assume this is a shop that that never keeps a stock of more than one thing. Right? So now we have a shopping list. Let's also have a stock list.
Okay.
And let's duplicate our shopping list.
Yep.
But we'll add breadsticks. I don't know why breadsticks is the first thing that comes to my mind.
Sticks, yeah.
And I don't know, rabbit.
Rabbit.
There we are. Gonna have breadsticks and rabbits. So now, if you scroll down a bit,
yep.
What we want to do is, Now, this is not really the way you do this, but I think it makes for a useful discussion. As we put something from the shopping list into the shopping cart, let's delete the same item from the stock list.
Okay. Yeah. So the way there's a bunch of ways of deleting stuff in Python. So we talked about append, right? There's a bunch of other stuff you can do with list. You can insert things into the middle of a list at the beginning. You can, instead of adding one to the end, you can take one away from the end. Now, a common problem, and I'll just show you this quickly. So say we have a list, right? And it has, I don't know, these numbers in it, right? It's got 4 numbers, right? And if I print out A here, then what we're going to get is, oh God, why is it doing this? Okay. So we've got a list here, right? We've got A and it has four numbers. Now, if I print this twice, you'll see it just shows the 4 numbers. Now, if you want to delete, say, I don't know, this 89 here, if I do del A and then I put the square brackets and I put in the index of the thing I want to delete. So if I put in 0, this is going to delete 5. If I put in 1, it's going to delete 32. But we want to delete 89, and that's at index 2. So what this is going to do is it's essentially going to remove it just like that, which is great. So if I want to remove this, it's just removed that way. And that's what we can do. So anyway, let's go back to this. So that's the way you delete by index in Python. So what did we have to do? Sorry.
I tell you what, I mean, I know this is a little bit more complicated, but what if we, every time that we wanted to get an item from our shopping list, we iterated through the stock list to see if that item existed.
Yeah.
And if it did, we added it to our cart and we deleted it from the stock list.
Okay, right. So we want to check if the item, so let's call it item just for, so the current item is shopping counter, and I'm only just doing this just because it reads nicer. Okay, so this is get the current item in the shopping list, right? Then what we want to do is we want to go through that list, right? This one here, stock, and check this to see if, if we're on beef, we need to go off to this list and check if beef exists. Now, in this case, it will. But say we had something like, I don't know. I don't know why, but my mind's gone blank. Something like chicken, right? So chicken, there's no item in this list in stock that has chicken, so it's not in stock. Bread is in stock, and you can see it being highlighted here. Mince is because it's here, but chicken doesn't exist here. We've got breadsticks and we've got rabbits, but we don't have chicken. So what we need to do is we need to go through that list and check to see if it's in there. Now, there's a couple of ways of doing this. So I'll show you those quickly, right? So say we have an array, 1, 2, 3, 4, 8, and 10, I guess. So one way of doing this is to just say, if you have 5 and you put in A, so what this is going to do is it's going to return true or false, and it asks this question: is 5 in this array thing? So if I run this, it'll say false because 5 isn't in here. But if I change this to 4, it's going to say true. So this gives us an answer. The other way of doing this is another way of iterating over lists. We used a while loop and a counter. The other way to do this is to just say for item in A, item. So this is going through each one in turn. So if I run
and actually,
this,
in other languages, you sometimes get these called for each loops.
Yeah, for each, just like this. So this is a for each loop. So what we're doing is I can change this to whatever I want. I could change this to variable or item or whatever. But what this is doing is this is going through each one in turn. This is becoming 1, then 2, similar to range. range goes 1, 2, 3, 4 up to whatever number you want. This, right? This takes on the value of like 1, 2, 3, 4, and this probably isn't the best example because we're going 1, 2, 3, 4. But if we took 9, 88, and 3, we'll see that this goes 9, 88, 3, 4, 8, and 10. It's going through each one of these in turn. So that's, and what we could do, is we could do something like if this item is equal to 4, then print, it's in there. And this is called a linear search. It says,
and just as a bit of a side note, if you are interested in the miracles of linear search, Ben's actually just done a fantastic video, literally just on linear search. It's not specifically for Python, but you can watch it on one of our other YouTube pages. I'm going to stick this in the comments as well. I've just seen there's been another question in the comment, which we'll come to in a second. But yeah, if you're interested in looking at linear search, we have a whole video just on that. Okay, so let's use. It seems like to me the for each approach is going to be the best way to check our stock and see whether it has rabbits.
Okay, so if we go here, and we'll do a linear search using for each. So if we do, I can't use item because we've already got something called item here. So let's call it for stock item in stock. So this is basically doing the same thing, but we're using a different variable name. Now, again, right, we can use some linear search. We can say if item. Now, remember, item is the current item in the shopping list. If item is equal to stock item, then we can say, then we found it. This item is in the stock list. So
and just to remind everyone from the example that's just been there, stock item will change. So that for each loop, that for loop will be going through checking each one, and at each iteration of the loop, so each step of the loop, it will be that stock item variable will be changing to the current index of the array.
Yeah. So what this is doing, as Chris said, right, is it's taking on the value one by one. So it's going to go eggs, and then it's going to be cheese, and then it's going to be crisps, and then it's going to be, and you can see how this is going until eventually we come to breadsticks, and then it's going to rabbits, and then when it comes to the end, it's going to stop the loop. And that's what this is doing, is it's going through each one of those in turn and taking the value. If it's eggs, for example, it's setting this stock item to that value. So what we're doing here is we're going through each item in the list, and this is a very common pattern you see in Python. A linear search, for example, is used almost everywhere. But what we're doing is we're saying if the item, the shopping list item, is in the stock list, then we want to do something here. So what did we have to do again, Chris, if it was in stock?
We're going to, if it's in stock, we're going to add it to our shopping cart, and we're going to delete it from stock.
Okay. So yes, so the I think we'd have to index into the thing here, so we might have to keep an index. There is another way of deleting in Python, but I can't remember that off the top of my head. But let me just check. Actually, we have stock item or stock. Is it dot delete? Got something? Well, we can have a look here.
Just use the del approach, I think.
Oh, here we go. It's dot remove. That's what it is. So del. The issue we have, right, is del takes a index, right? We have to put an index in there. But what we want to do is we want to take the value of something like eggs, for example, and delete something with the value eggs. The way we can do that is we can do stock.remove, and we pass in the value of something. So in this case, stock item, and that removes it by value. Now, that might be a bit confusing.
The first instance of that. So if we had, say, cheese in stock, if we had 3 cheese in stock, and we did the dot remove, it would only remove the first time that it found the cheese value.
Yeah. So if this dot remove is confusing you because we just talked about del, there is a slight difference between the two. Del, what you do with del is you say, hey, I want to delete this item at this index. You say, I want to delete index 2, please, and it goes off and it deletes index 2. We've got the opposite problem. We don't know what index, say, I don't know, cheese is at. We can look at this and go, oh yeah, sure, it's 1, right? But we need to be able to say, I don't know where cheese is in the list, but I want to delete it, please. Now, what that remove does is it doesn't really care about indices. It goes here and it just goes, is this cheese? No. Is this cheese? Yes. Okay, so remove it. That's what it does. So what that's doing is it's removing this stock item from the stock list.
But only if it's equal to the item that's on our shopping list.
Yeah. So that's if the item matches the stock item, and I assume got the is in here.
Yeah. So we've found it in stock. We're now going to add it. What happens though, Ben, if we get all the way through? So let's go back up to our shopping list.
Yep.
It's chicken. And they ain't got chicken. They got rabbits. They ain't got chicken. So what happens if it doesn't find the item? Can we print it? Can we get it to print a different message?
Yes. So here, right, this if item is equal to stock item, this is testing if, I want to get beef. It's going to say, oh, right, there is beef in stock. Now, when it comes to chicken, it's going to ask that question, but it doesn't find it, right? So that becomes an issue, right? How do we do that? Well, now what we have to do is somehow kind of detect whether or not this linear search has failed. So if it hasn't found anything, then what we need to do is remove it, or do something with it, right? So we can print out.
Can set up, there's loads of ways of doing that. One where I one of the first ways I was ever taught was having a flag.
Yeah.
So you have a variable where if something, so let's call it success or found. Yeah, found.
Okay. Yeah.
And we're going to set found to false.
Yep.
And if we actually find it, we'll set it to true. But if we get to the end and it's still false, we know we didn't find it.
Yeah. So if we've come past the end here and found is equal to false. So what's going to happen is if we found what we're looking for, this is going to be set to true. So at this point, if found is true, but if found is equal to true, then we found the item. We can do whatever we want. But we're looking for the opposite. We're trying to see if found is not true. So if we haven't found something, then we can start doing something with that, right? So what we need to do is, and just before I forget, I'll just put this counter above here so we iterate to the next one. We'll change this to false, and we can say something like
don't got the and then plus shopping cart. Actually, it wouldn't be counter, it'd be counter -1 here because we're adding one before. So what we're doing essentially is saying don't got the and then doing this, right? Actually, could we not just put the counter after that?
Yes, I in my head I was thinking that we'd break from it and then don't worry about
You're
that.
You're thinking different languages now.
Yeah. so yeah, if we haven't found it, then we just print don't got the and then the item. So in this case, we know it's going to be.
We've got another problem though, haven't we, Ben? Because because we're breaking out this loop by saying if the length of the shopping cart is the length of the shopping list.
Yeah.
But we don't got the chicken, so we'll sit in this loop forever. Because we will never have our chicken.
Mm-hmm. Yeah, I see what you mean. Yeah. So in the worst case, right, we could have a shopping list where nothing is in stock, right? We could have 5 items in here and none of them in stock. And we just keep going because the length of the shopping cart is not equal to the length, because we're never adding anything to the shopping cart. So the question is, how do we circumvent that? And there's a few ways of doing this, and off the top of my head, I'm trying to think around how we could do this. Have you got an idea, Chris?
Yeah, so the way I would tend to do it is I would check the length of the counter. against the length of the shopping list, rather than see whether the cart and the shopping list are the same length.
Yeah. Okay, so if
the way that we've laid, there's loads of different ways of doing that. I mean, you might also have another array where you're detecting. We've got that. Have we found the item? Have we not found the item? We sometimes will have like a list. Sorry, that's just holding those successes. But in this case, I think the easiest way is just check against the counter, because that's where we keep our current index in that loop.
Yeah. So counter is always going to increment, right? Because counter is going through each one of these in turn. Now, this should work because counter is adding 1, and if the counter is equal to the length of the shopping list, this means we've gone through that many items. So we can try this. I'll run this and assume it all works. And as predicted, we've got the eggs, got the cheese, and finally at the end we've got the chicken, right? So just
what would be really interesting to do, though, let's do that again, but let's print the stock at the end, so we know what we have in the stock at the start.
Yeah.
Let's print right at the end, after the last line of the code. Print the stock.
Print the stock. Yeah. So, and I'll just for clarity, I'll print out stock before the loop as well. So,
I'll tell you what. Instead of doing that, just scroll to the top of the code so we can just see what's in the stock.
Yeah. Oh yeah. Okay. Gotcha. So let's run that. So we started off in our stock with eggs, cheese, crisps, bread. Beef, mince, beef, and
you hate the fact that I put mince and mince in there, don't you?
It's like a tongue twister. Bread, breadsticks, and rabbits, right? And you can see that we started off with this in our stock, but now you can see that we've only at the end of this got breadsticks and rabbits left. So we're removing stuff from the stock. If I removed cheese from this shopping list, you can see that cheese is still in stock.
And similarly, if we added, let's say we want to buy a cow.
Yeah. Okay. We got eggs, cows, cheese. So if we run this, list index out of range. Not too sure what's going on there.
I'm assuming that's it's. I think that it might have cached something from the previous loop.
Yeah. So if we add it at the end, it's fine. But you can see,
don't
got the cow, right? So this is one way of doing this problem, and there's a bunch of different ways of doing this. There's a bunch of different.
It's only funny. Do you remember that old cartoon show called Cow and Chicken?
Yeah.
I just love the don't got the chicken, don't got the cow. Sorry, that's a topical cultural reference from the early 90s. Ben don't got the chicken, Ben don't got the cow. Sorry.
Yeah.
Oh.
So there's a bunch of different ways of doing this, right? I mean, for the people who probably know a bit of Python before watching this, you might be going, why are we using a while loop, and why are we doing a linear search when we can just use the in keyword, and why are we, doing things a certain way? The idea is that this is just one way of doing it, and algorithmically, this is kind of what's going on behind the scene with the in keyword and so forth. But basically, there's a ton of different ways of doing this, and the reason we've done it this way is to show you how to use a list, how to manually remove stuff from a list, how to add stuff to the end of a list, how we can index into a list, and so forth.
Python's got a lot of really useful functions that are built in. Like I say, there are functions that will just do a lot of this for you. In fact, you could probably slim this program down into 4 lines of code.
Yeah.
Just as I'm looking at it now, in fact, I think you probably squeeze it into 3. But there was kind of those quick functions, that there's cool things that make Python cool in its own way. They're a lot more useful if you know what's happening behind the scenes. So what we've gone through here again, that we've used different types of loops. So we now know what a while loop does, and we have that counter, and we know what a for each loop I don't. Do they call it a for each loop in Python? I don't think they do they?
I'm not sure actually.
I
call it a for each.
But we know what those do, and like I say, that behind that we've got a linear search, and ultimately you might be using the fancy function, but behind the scenes you're doing linear search. And so just before we move on, and I think now we've got to this point, I think it's worth thinking about what happens if we've written that list in Notepad and we brought it in as a separate file. So we did say we were talking about files, so we'll do that in a second. But let's just if you just go through each line of the code and just explain what that does, just because we say that we don't really prepare these episodes. We start off with an idea of what we want to do and it slowly evolves, right? So it can we do bounce through topics quite a lot. So let's just go through each one and just explain what's happening.
So this first line of code, this is making a list called shopping. And in this, shopping list of things we need to get, we've got all these things, right? There are some things which are in stock and some which aren't. Yeah. So stock is, another list, and this is what's in stock in the shop. So we can see that the shop's got eggs, cheese, crisps, beef, and so forth. And the rest of the code is about solving this problem, right? About having a shopping list, going into a shop and buying stuff which is either in stock or not in stock. So we have a shopping cart, which is a list which is currently empty, and we have a boolean called is shopping, and this is initially true, and it will stay true until we finish shopping. We have a counter variable as well, which is initially 0. So what we're doing is while is shopping is equal to true. Now, initially, this is true, so it's going to firstly go into this loop. But whilst we're still shopping, and we'll get into, how this becomes false, but get the item in the shopping list at counter. Now, counter, it starts off at 0, and down here, we add 1 to counter. So what's happening in this loop is we're going through each one of these in turn. We're going to eggs, we're going to cheese, we're going to crisps, and so forth until we end up at cow, and then we stop. Now we've got a variable here called found, and we're doing a linear search here. So this, if this stuff gets a bit tricky, because you're not used to like loops and loops and this kind of stuff, then don't worry too much about it. But what we're doing is we're iterating through each item in the stock list. So we're going eggs, cheese in shopping list, crisps, and for each one of these, say we go to cheese, what we're doing is we're going through this stock list and saying, hey, actually, is cheese in stock? So we go to eggs. Is this cheese? No, it isn't. Is this cheese? Yeah, it is cheese. Cool. So it's in stock. But say we've got cow, it's going to do the same thing. It's going to go, is this cow? No. Is this cow? No, it's cheese. Carry on until we eventually get to the end. And it hasn't found a cow, right? So a cow isn't in stock. So that is a linear search. And like Chris said, if a linear search is confusing, we do have a video on it that I made very recently. Have a look at that. But essentially, that's what we're doing is we're checking each item in the shopping list against if it's in the stock list. Now, if it is in the stock list, then we add it to our shopping cart. Now, remember, if the item is in stock, we're just adding something to our cart. Then we're setting found to true. So we can actually say, hey, we found the item, and we can do something with that. Stock.remove actually just removes that item from stock. So say we find cheese, it's in stock. We're removing cheese from the stock list. And then finally, we print out, got the whatever. Now, if we didn't find anything, then it just says, don't got the. Like, don't got the chicken, don't got the cow. And then we're adding 1 to our counter. Then this is the condition which we exit the loop if the counter is equal to the length of the shopping list. So remember, this is going up by 1. So it's going to start at 0. It's going to go to 1. And it's going to keep on going through each one of these until it eventually hits here. Now, when we reach here, this is going to be the same length as the shopping list. So it's going to run this code and set is shopping to false. So what we're saying is here, if you've gone through all the items in the shopping list, then set is shopping to false. And then this loop here, this condition, is no longer true because this thing is shopping will be false. So it exits the loop and prints the stock.
So let's let's see how we would do that if that shopping list was in a separate file.
Okay. So the first thing to mention is how we create files in Replit. Now, for most of these lessons, we've talked about the code here. This is the code window, and this is the output. There is another bit here. As you can see, it says files. So there's a little icon here, and we can say add file. Now, you can upload your own files and so forth, but I'm just going to create one. Let's call this...
We'll probably talk about uploads when we start doing a little bit data analysis.
Yeah. So we'll call this, I don't know, shopping.txt. So it's just a text file. And you can switch between files like this by clicking main.py and shopping.txt. Now, main.py is the code that we're going to run. .py is for Python, and you can see the little icon here. But here's a shopping list, right? There's nothing in it at the moment, but you can think of this as an actual shopping list. So we can put in things like eggs and bread and milk and
chicken,
cheese,
cow,
and raccoon or something.
Are we literally just going through 90s TV shows now?
We're just going.
Do you remember the Raccoons? That was a good show.
I don't remember the Raccoons.
The Raccoon was a great show.
I thought we were just listing random things like traffic cones or something. Just random stuff. Desk. But it's a very weird shopping list. But this could be a shopping list, right? And this, you could feasibly do this. You could just open up Notepad, type in stuff into a text file, and that could be your shopping list. Now, the question is, how do we take this and actually get it into our Python stuff? So what I'm going to do is, well, for now, I'll just comment this out, but we'll come back to this. I'll show you how to read from files in Python. So here we have a file called shopping.txt. The question is, how can we actually read data from this file? So it's actually quite easy in Python. What you do is you do file equals open, and it says here file open mode. I'll write this and I'll talk about what it means later. So this is opening a file, right? Open is open a file. Here we pass the name of the file. So as you can see,
that was just a little bit confusing, Ben.
Yeah.
So the first item there, we said that's opening a file. It's the next bit that it might be worth explaining what that first bit of the code, because that's something that everyone's seen before.
Right. Okay. So this thing here, open, is opening a file, right? Now it's storing something in this file variable. Now this file is a variable, just like any other variable. And don't worry too much about what all this stuff is. For the sake of not getting into the nitty-gritty details of classes and modules and this kind of stuff, I won't really talk about what's in here. But basically, you can think of a reference to the file here. It's opened the file and it said, "Oh right, okay, a reference to the file is here." I'm not too sure.
I think the way I've always kind of thought of this is, right, we're creating a variable called file, and we've put the contents of that file in it.
Yeah.
It's not exactly what's going on, but I think that's an easy way of looking at it.
Yeah, for the sake of simplicity now, just imagine that. Just imagine it's got the contents of the file in here. Now, behind the scenes, that's not the case, and if we get into the details, it'll just confuse you. So just imagine that this is opening a file, right? In this case, shopping.txt, like the one here on the left, and it is saving the contents of that file into this variable called file. Now, the next thing that might be a bit confusing for you is this R thing, right? And the reason this R thing isn't here is because Python, when you open a file in Python, you can actually open it to read, or you can open it to write, or you can open it to append and so forth. This is called a file mode. So we want to read data from this text file. We don't want to write things or add things to the end of the shopping list. All we want to do is read stuff from this shopping list. The next thing is this file.close. Now, file.close, it's very important. Once you've opened a file, you must close it at the end. It's similar to, if you open up your shopping list in Notepad or Word, you write stuff to that or read stuff from that file, and then you close down Word.
Clearly don't know how I use my to-do lists.
Yeah.
I've open Word document for weeks now.
Yeah. Now the reason we have to close the file is, again, I don't want to go into the details here, but basically, if you don't close it, it's going to stay open forever. If you've ever opened a file on your operating system, I don't know about you, I've done this tons of times. Say I've opened a spreadsheet, and I try open it again, it will say, "Oh, you can't open this because it's being used by another process." Basically, this is the reason. If you don't close it, you can't access it again. So just make sure whenever you've got an open that you've also got a close in somewhere. So what we're doing is we're opening this shopping.txt file here, and we're opening it to read data, right? And we're saving the contents of that into a variable called file. And then finally, we're doing nothing with the file here at the moment, but what we're doing is we're just doing file.close. So if I run this, it prints nothing at the moment. So how can we actually get data from this file? So the standard way of getting data from a file is to just do for line in file, and let's print the line. So you can literally go through this just like a list, right? So if I run this, you can see I've got eggs, bread, milk, cheese, chicken, cow, raccoon. And if I add something onto the end of this, like I don't know, goat's cheese, you can see it's added to the end. So we can keep all our data in a file somewhere and read it in with Python. Now, the next thing you're probably wondering is, why is there these big spaces between here? And this is because, well, if print line, if I do two print statements like hello and world, I'm not going to type there because you can see that these are on separate lines. You've got hello and you've got world. So what's happening is it's adding a new line character there. So \n. And I think we talked about this in previous lessons, or one of the previous videos anyway. Now, what this \n does, and I'll remove this just so it's a bit more clear, is, so if I add a \n, this is adding another line. If I add another one, it's adding another line. So I'm increasing this gap between them. Now, what's happening is in this file, right? Basically, each one of these has a hidden new line like this at the end of the file. So how do we get rid of that? Well, one way we can do it is to just do line.rstrip. What rstrip does is it gets rid of like things like that new line character. So now everything's on a nice little thing for us.
So Ben, how can we put that in an array?
So we did something similar to this before. We used, we added stuff to a shopping cart. I mean, it's commented out here, but you can see we added stuff to a shopping cart, right? We added on to the end of a shopping cart. Essentially, we need to do the same thing here. If we have items, right? Currently, items has.
I'll tell you what. Let's just call it shopping. We'll just get rid of our shopping list array.
Yeah.
And then all the rest of the code will work.
Okay. So we've got shopping, right? Shopping is currently empty, has nothing in it. What we're going to do is this stuff. We know this stuff is printing out the actual value of each one of these lines in this file here. So what we're going to do is we're going to do shopping.append and that thing. And now, once we've closed the file, I'll print out shopping for you. So you can see that this is initially empty. It has nothing in it. But we're going through each line in this file. So we're going through eggs and then bread and then milk and then cheese. And we're adding each one of those into this list. So as you can see here, the last item is goat cheese. If I add, I don't know, pizza at the end here and I run it again, pizza magically comes into this array. And this is
with magic of code.
Yeah. Now these two things that are lists and files, you might be thinking, okay, yeah, this is great, and I don't know why Ben's getting so excited that it's magically appeared here, but this is like the core of data analysis. You can have, imagine this isn't a shopping list. Imagine this is a list of values, right? And you want to do some analysis on it. You can read that from a file, shove it into some kind of list or array or whatever, and then you can start doing analysis on it. And it's that easy, you know. In a few lines of code, we've read everything from this file, and we've
shoved it. We're going to actually have to do next week. We're going to actually have to do some data analysis.
Yeah, and
keep practicing, keep teasing that bit of data analysis.
Yeah, and we've shoved it into a file, and shoved it into an array, and now we can start doing stuff with that, right? So for example,
let's comment our program. Let's show how that now works.
So we've still got stock and the shopping list here, so everything should work fine, right? So let's uncomment this. Now our shopping list is eggs. Well, it's basically what we had before. Now, if I run this, we get the same error that I think basically is it. I think it's because I put chicken here. I'm not too sure. Actually, I think it's because we have different items in here. Let's just. If I do this and I put in. If I put these in manually, eggs, cheese, crisps, beef, mince, bread, breadsticks, rabbits, right? So that's everything in stock. We minus off that. Let's put in pizza again. Let's put in, I don't know, traffic cones for some reason. I don't know what else. Goat's cheese was in there, right? So we've got these things as well. So let's run this with this list, and as you can see, it says don't got the pizza, don't got the traffic cones, don't got the goat's cheese. If I want to add on to the end of this something like yogurt, it just automatically says don't got the yogurt. So I can keep all my data nice and neat here in a file, right? I could maybe just have 4 things on my shopping list and run this, and it can say got the eggs, got the beef. So my shopping list can exist in a completely different thing, and what we're doing is we're just reading it in through here. And that's one of the most powerful features of Python and using it for data analysis, is that we can just keep our data somewhere else. We don't have to clutter up our code, and we can just read it exactly like this.
There's one last question, and then I think we're going to need to call it a day. Mm-hmm. Can you do shopping? Can you write that? No, it's just on the screen.
Yes, sorry, I didn't have the tab open. Can you do shopping 0 to 6? Yes. So if you're talking about indexing in Python, so you can do slicing. This is called I think it's slicing or splicing. I'm never too sure. But ideally, yeah, what you can do is you can have a list of things. Let's call this numbers or something. And you can do.
Yeah, let's do one with numbers, because there's one last thing I'd like to mention.
Okay, so there's another thing in Python, as this comment is kind of getting at, is we can print out 0 here, right? So we can print out 9. We can print out 1, and this is 5. But what we can also do is say 1 to 3, right? Now what does this do? Well, it gets the portion of 1, 2, 3. So it's going to get this. If I put 4.
Now it might be worth talking about inclusive and exclusive indexing here.
Yeah, so
that might have confused people.
Yeah, so okay, so 3 here. This is saying go from 1, start here at 1, and go to 3. Now 3 is here, but this is would that be
1 is inclusive?
Yeah,
and 3 is exclusive, which means says when you start from 1, use the number in index 1. But then stop before you get to number 3.
Yeah, so it's gonna this portion basically. So this is 1. So 5 is index 1, 3 is index 2. This is index 3, but because this is exclusive, we don't use that. So if we wanted to actually get this, we'd have to use 4. And there's different ways of using this syntax. So if we use the original. If I add some more numbers here like this, if we do 0 to 6, this is going to get us the first 6 numbers of this thing, and that's why it's exclusive, because if we put 6, we want 6 numbers back. You can omit this, and it will give us the whole thing. You can also do up to 3. This is going to give us this, and we can increase this. So there's a bunch of different ways of doing this. And if this syntax is a bit confusing, don't worry, because this is actually it's quite an advanced feature of
the only other thing that I thought was worth doing is summating a list. So when we have a list of numbers, and we do this a lot in data analysis, and we're going to do some data analysis. So how do we summate that list? How do we add all those numbers together?
So let's put something like list sum equals 0. Right. So here we have a list of numbers, and we want to get their total. So how do we do that? Well, we can go through each number in numbers like this, and we can do list sum plus equal number, right? And then print out the list sum. This is what's happening is, as we know, this for each loop, and I could call number whatever I like, but I'm just calling it number. This is going to go through 9, 5, 3, 2, and so forth. And what it's going to do is it's going to add on to this list. And this is very similar to what we saw before when we were talking about iteration, where we had, I can't remember the example. I think it was like a running cost and like your rent and your expenses. We were doing this kind of thing. But what we're doing now is we're going through each one of these numbers. We're going 9, 5, 3, 2, and we're adding those to a sum. So let's run this. We get 49. Now, if I add 1 here at the end, we'll get 50. So this is a very useful thing. And as Chris says, we use this quite a lot in data analysis, but also generally when we want to do things. And there are ways of doing this. Some people might point out that there's inbuilt methods like sum for doing this in Python. You could also do it through list comprehension. There's a bunch of different ways of doing this, but this is one of the ways of doing it. We actually loop through this list of numbers and add it to a sum. And you could do something like divided by the length of list sum. And this will give us, this is my bad. Numbers here. The average is 5. So we can do all kinds of stuff in this.
Brilliant. So we'll call it a day at that. We have gone a little bit over time. Hopefully that was useful and worthwhile going over time. Let's say next week we've now, I think it's fair to say, Ben, we've got all the kind of core components of doing a bit of data analysis. We can work with data. We know how to read data in. We can iterate over it. We know how to use variables. We've done some operators. We know how to do a little bit of math in Python. So next week we'll take some data and we'll do some sums. Brilliant. So thank you to everyone for watching. I hope you enjoy this, and thank you very much. Cheers.
Thanks, guys.